Hey class, this is a recap of lesson 1-3. We did this on the 17th, 8/17. And this is going to be a quick recap of lesson 1-3 on locating points using ratios. This is going to be the first of two videos. First off, we just did a quick recap of what ratios were. Ratios are a comparison of two numbers, or possibly more. You could have three numbers in a ratio. Ratios compare numbers in different ways, similar to fractions. The order of how the ratios are stated will affect the order of the numbers you write. Ratios are typically simplified so that the greatest common factor of the parts is 1. So, two quick sort of examples here. The number of triangles to the number of squares in this picture. Notice that they're listing triangles first. The little colon here means compared to, the number of triangles compared to the number of squares is 4 compared to 12. I see 4 triangles. I see 12 squares. I'm writing it as 4 to 12 because I saw triangles listed before squares. We could simplify that ratio to 1 to 3. If I was asked about squares to triangles, I'd say 12 to 4 or 3 to 1. That's comparing parts of all the shapes here. So it's comparing like this group to a separate group. You might occasionally see ratios as comparing a part to the entire thing. So number of triangles to the number of shapes is 4 to 16 or 1 to 4. The number of squares to the number of shapes is 12 to 16, or 3 to 4. We did a handful of quick examples. If we had like 10 circles and 2 squares, the simplest ratio we would have said for the squares to total shapes, well, let's start off with saying 2 squares to 12 total shapes, and simplify these by dividing by 2, get 1 to 6. If we know one ratio is 1 to 6, and we're then trading it for circles to total shapes, well, let's start off by listing the circles first, compared to the total shapes as 12. Simplify it, becomes 5 to 6. Notice 1 compared to 6 and 5 compared to 6 are kind of like fractions. They are kind of like 1/6 and 5/6. 1/6 of the shapes are squares, 5/6 of all the shapes are circles. Simplest ratio of squares to circles, I'd write 2 to 10 to begin with and simplify it to 1 to 5. Notice that we're just sort of basically comparing the numerators here. The number of squares compared to the number of circles is basically just comparison of the numerators. If I then ask about circles to squares, I can just reverse this. We could say it's 5 to 1. It's the same question, but the order it was asked was reversed, so the numbers I need have to be reversed as well. We did this briefly just to review it, because you're going to see a handful of ratios throughout the real topic, which was locating points using ratios. We're going to try and partition a segment, a line segment, on a number line and on a coordinate plane. We're just going to do the number line today. We're locating points on a number line using our section formula here. We're being asked to find B on the line from A to C, such that the ratio of A to B to B to C is 3 to 4. This is a long way of saying A to C, we got A to C, and B is going to be somewhere here. B is going to be somewhere on the number line, possibly at -2, possibly at 0, possibly at 2, somewhere on the number line, so that wherever I put that dot, the less the distance from A to B and the distance from B to C follows the ratio of 3 to 4. This length would be some compare ratio. So we could try this as a quick visual thing, just to see it. A to B here currently has a length of 3. Going from -5 to -2, it has a length of 3. B to C currently has a length of 9. So the ratio of AB to BC is currently 3 to 9, or 1 to 3, which is not the 3 to 4 ratio that we would want. But that's the idea. We're going to learn how to find out where B is when we're told what the ratio is. And then we could use this method to check. To use this ratio and to find B on the way from A to C, we're just going to be using this formula. This formula requires that you know 4 specific numbers. Requires that you know N and M. N and M are the ratio that we want to use. The 3 here is our M. It's the first number in your ratio. 4 here is the second number in your ratio. It's N. M is 3, N is 4. It's always going to be that order. When you're told a ratio of M to N, when you're ever told a ratio, it'll be 3 to 4. So up here, this 1 to 4 would have been M and N. The 4 to 12 would have been a ratio of M and N. Whenever you're asked for the ratio using section formula, M and N are always the ratio in order. The other thing we need is x1 and x2. x1 is our starting coordinate, where we're starting on the number line. x2 is where we're ending on the number line. They will also have to tell us that information. x1 happens to be A. x2 happens to be C. Or more specifically, where it's located. Where is C located and where is A located? I see A is at -5, so I'm going to put an x1 there and circle that. A is at -5, x1 is -5. I see C, my second point. I'm traveling from A to C at a ratio of 3 to 4. C is x2. Once I've identified 1, 2, 3, and 4 numbers, we just need to plug them in. It's just multiplying, some addition, and some division. Seeing that here, we're going to go N, the second number in a ratio. N is 4, times x1. x1 is the location of A. 4 times -5. Plus M, M is 3, times x2. x2 is C's location, 7, divided by M plus N, divided by 3 plus 4. We just need to evaluate this carefully. I'm going to give myself a little space. We get -20 plus 21 from our multiplication up here over 7, which simplifies to just 1 over 7. This would be our location on the number line. We'd want to put a dot at 1/7, and that would be splitting this number line in a ratio of 3 to 4. This particular example is not great because you can't see or check yourself to see the ratio of 3 to 4 on it. So we're going to do the now you try, which will be easier to see the ratio example. We're going to find P somewhere on the line A to F, such that the ratio of A to P, the length from A to P compared to the length from P to F, is 1 compared to 3. Again, we just need to identify 4 numbers. We need 4 things. We need to know what x1 is, what x2 is, what m is, and what n is. We need to know those 4 things to solve this problem. x1 is where we're starting on the number line. We're starting at a and going to p. So a is our x1. It has a value at negative 15. F is where we're ending on the number line. We're going from A to P, and from P to F. We're ending at F. F is our x2 location. It's located at 1 in this case. And our ratio is always written in order m and n. M will be 1, n will be 3. We'll plug those into the exact same formula. Into the exact same formula that we have here to find what P is. P equals n, which is 3, times negative 15, or x1, plus m, which is 1, times our x2, which is also 1, all over 1 plus 3. We get negative 45 plus 1 over 4. We get negative 44 over 4, which is the same as negative 11. P would be at negative 11. Let's mark that really quickly on our number line. This will be where P is. And we'll do one last thing to just help us convince ourselves that it's right. We'll check our work here. From negative 15 to negative 11, this distance that I'm coloring red is 4 long. From P to F, going from negative 11 to 1, that has a distance of 12. If we compare 4 to 12, if we compare AP to PF, we see that 4 to 12 simplifies to 1 to 3, the ratio we wanted. This is just a good way to check your answer. We know P is at negative 11 because negative 11 splits the distance in a ratio of 1 to 3, or similarly 4 to 12. You had a homework related, or you had a classwork that you had related to this. The classwork you had, I had you open up the textbooks this day, and you worked on page 27 of your book. Generally, I was asking you to do 1 through 6 or 1 through 7 if you were in the honors courses here. You were doing this on the back of these notes. You had taken this page that you had just taken notes on, flipped it over, and started working on 1 through 7. All right. Make sure to submit this to me. Have a good night.